going to pick up where we left off yesterday. Sorry, let's focus that. So we are continuing the 3.4 and 3.5 parallel and perpendicular lines. And yesterday when I left you, we had just talked about the fact that parallel lines have the same slope and that perpendicular lines have slopes that are opposite reciprocals, or basically the products of those slopes equal -1. And that's exactly what these two theorems state. So slopes of parallel lines, basically in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So parallel lines, same slope. And any two vertical lines are parallel, right? Also any two horizontal lines are parallel. Perpendicular lines in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is -1. So perpendicular if product of the slope is -1, or the way that I like to say it is that they are opposite reciprocals. And here they say that horizontal lines are perpendicular to vertical lines. Okay, so let's talk about the slope of vertical lines and horizontal lines real quick. So I'm just going to come over here on the side. Let's first talk about a vertical line. So I'm going to make a coordinate plane. And I'm going to graph the line x equals 2. So just pretend like that's 2. And so then this is the line x equals 2. Which basically means that on this line, no matter what y value I have, my x value is always 2, right? So this would be, let's just pretend, 2, 1. And then this is 2, 2. And then this is 2, 3, right? Corresponding with different points along the y-axis. All right, well, let's talk about the slope of this. So the slope of this line, well, we have a rise, right? So we can choose any 2 points. Maybe I go from this point to this point, and I get some rise. So I'll just call it for this right now 1. So saying I went up 1 unit. But I have no run. I have no sideways, right? Okay, so my slope is 1 over 0. The question is, what does 1 over 0 equal? 1 over 0 is not 0. Let me just come up here and prove that to you. If I take 1 and I divide it by 0. 0 times what will give me 1? There's nothing in the world that I can multiply 0 by that when I multiply those, I'm going to end up with 1. There's nothing. So we actually call this undefined. Okay, so any vertical line, first of all, any vertical line, the equation of a vertical line is x equals whatever the x-intercept is. The slope of a vertical line is always undefined. These are things you need to remember. The sooner you do it, the easier your life is going to be. Second thing that we're going to talk about now is horizontal lines. And again, I'll just come over here and graph a coordinate plane. So a horizontal line, let's do y equals 2. So y equals 2 is a horizontal line that goes through the point y equals 2. Right? So for every single input, no matter what they are, 1, 2, 3, and so on, every single input, the output is going to be 2. So a horizontal line always looks like y equals whatever the y-intercept is. See, these guys, they don't have like slopes that you can put into these equations. So writing them in slope-intercept form doesn't really work. Okay, so let's talk about the slope of this one. So the slope for this guy, well, what's my rise? To go from this point to this point, I didn't rise at all. So no rise, but I can run, right? So to go from this point to this point, we'll just pretend like that's 1 unit. That's 0 over 1. Okay, and so the question I pose to you is 0 divided by 1 is what? Well, 1 times what will give me 0? That is correct. It is 0. So the slope of this is actually equal to 0. Okay, so your slope here is equal to 0. So one more time, vertical lines, slopes are undefined. Vertical, if you don't know what vertical versus horizontal is, you got to learn that first. And then a vertical line will always be of the form x equals whatever the x-intercept is, wherever it crosses the x-axis. A horizontal line is of the form y equals 2 or y equals whatever the y-intercept is, wherever it crosses the y-axis, and its slope is going to be 0. The sooner you learn those, the easier it's going to be, because those lines keep coming up again and again and again. All right. So, using these theorems, let's go through and talk about identifying parallel and perpendicular lines. Determine which of the lines are parallel and which of the lines are perpendicular. Well, any lines with the same slope will be parallel, and any lines with opposite reciprocal slopes will be perpendicular. Okay, so I'm going to find the slope of each line. So I'm going to do slope of A. This is like M is for slope. Sub A means line A. Slope of line B, slope of line C, and slope of line D. And then we'll compare all those. And remember, to find your slope, it's basically y2 minus y1 over x2 minus x1. Or you can count, right? You can count rise over run. These might be a little bit challenging, because when I look at them, I notice that my units are going by 2s. And some of these points are like in the middle. So that could be a little bit more challenging, but it's totally up to you. I'll do it both ways. How does that sound? So for line A, I will start with these 2 points. So if I take the change in the y's, that would be 4 minus 1. Well, that's just going to be 3. And if I take the change in the x's, that's going to be negative 4 minus negative 3, which is really negative 4 plus 3, so that's negative 1. So that gives me a slope of negative 3. I also could have just counted and said, well, from 4 down to 1 is minus 3. And then from negative 4 over to negative 3 is positive 1. So it could have also just been negative 3 over positive 1, which would still give you negative 3. Either way, you need to recognize that this is a negative sloping line. We read from left to right. It is going down from left to right, so you should have a negative slope. B will also have a negative slope. Okay, so I'm going to do the same thing. I'm going to choose any 2 points. So how about I'll choose these 2 points. From 4 down to 1 is 3. And then from 6 over to 7 is, wait a minute, am I doing something wrong here? From 6 and then subtracting 7, that's going to be negative 1. So that's negative 3. Right? Or you could have said to yourself, yep, that's a difference of 3. And then from 6 to 7, I go over 1. All right. Let's see. The slope of line C. So this is line C here. I'm going to choose any 2 points on there. I'm going to do the exact same thing. So I'll subtract the y's and then put it over the subtraction of the x's. So 1 minus 4 is negative 3. And negative 3 minus 6 is negative 9. That gives me a positive 1/3. I'll do the same thing for line D, so any 2 points that I can find on there. So how about these guys? Okay, and I'll go from negative 2 minus negative 7. Well, negative 2 minus negative 7 is negative 2 plus 7. So that's going to give me 5. And if you have to write these out, write them out. And then 8 minus 0 is 8. So I get 5/8. Okay, again, you can just sit there and write this formula out, and you can find all these numbers as well. All right, so any parallel lines are going to have the same slope. So I know the same slopes here. So I know that line A is parallel to line B. And then I'm looking for opposite reciprocals for perpendicular lines. So I can see that this line here is -3 or -3/1. And when I flip it, I get 1/3. And take the opposite, this was negative, take the opposite, it's positive. So these are going to be perpendicular as well as with A. So line C is perpendicular to line A and to line B. So I'll say line A perpendicular to line C, and also line B is perpendicular to line C. And that makes total sense because these two lines are parallel. So anything that's perpendicular to line A will also be perpendicular to the line that's parallel to line A. All right, next one. Writing an equation of a parallel line. So we're going to write an equation of the line passing through this point that is parallel to this line. Well, this line is given to us in slope-intercept form. So right away, I know the slope, right? My slope here is 3. And if I'm looking for a parallel line, the slope is going to be the same, right? Because parallel lines have the exact same slope. So I like to write it like this. My parallel slope, that just means parallel slope, is also going to equal 3. So my new line will be y equals 3x plus b, right? For m, I'm going to put 3 in there because that's the slope I'm going to use. Definitely not the same y-intercept, though. I am not using this same y-intercept. They are parallel. They are not coincident lines. So now I have an x and a y that I can use to plug in and figure out what my y-intercept of this parallel line is, the line that's parallel to the original line. Okay, so I'll plug 6 in and -4. Okay, and now I got to solve. So 6 equals, let's see, that's -12 plus b. Add 12 to both sides, trying to figure out what our y-intercept is. So b equals 18. Okay, so the equation of the line that is parallel to this has the same slope, but it has a different y-intercept. It has a y-intercept of 18. So my parallel line is y equals 3x plus 18. All right, next, write an equation of the line passing through the point -12, 6 that is perpendicular to the line y equals 2/3 x minus 10. So again, so my slope right now is 2/3, but I want the perpendicular slope. And perpendicular lines have opposite reciprocal slopes. So this one's positive, so I know I need the negative. And then I also need the reciprocal, so I'm going to flip it. So that's the perpendicular slope. That's what I'm going to put into my slope-intercept form for my line that's perpendicular to this line. Again, it's not going to have the same y-intercept. They're perpendicular, well, unless they're perpendicular on the y-axis to each other, if that's where they intersect. Okay, so let's see what we get. So I'm going to plug this in for my slope. And then I'm going to take the point I've been given. There's a reason I've been given this point. It's so that I can actually find what the y-intercept is. So I'm going to go ahead and plug that in. So 6 for y, -12, or -12/1 for x, plus b. I only put the 1 there because I'm dealing with fractions here. And in order to multiply fractions, you need numerators and denominators. Or it makes it a little bit easier. Now I can sit here and I can say, all right, I can reduce these, right? So 2 and 12 have a common factor. They can both be divided by 2. Divide bottom by 2, you get 1. Divide top by 2, you get 6. This is 18 plus b. Solving for b. Oops, why am I writing 12? Minus 18 from both sides. So b is going to equal -12. So now I just take that and I plug it right back up in here where my b is. So the perpendicular, or the equation of the perpendicular line to the line we were originally given, is y equals -3/2 x and a -12, or plus -12, however you want to write that. All right, one more problem to do, and it's a doozy. This is a very long problem with several steps. So I'm going to try really hard to walk you through this. All right, so we're going to find the distance from the point 6, -2 to this line y equals 2x minus 4. Okay, so I've got some point, I've got some line. Let's just pretend that my line right here looks like this. Well, actually it would. Just pretend though. This is y equals 2x minus 4. And then I have some point out in space. That is 6, negative 2. And I have to find the distance from here to here. And if you remember, from the very beginning, the distance from a point to a line is the length of the perpendicular segment from the point to the line. So what I have to do first is I have to figure out this perpendicular segment. Now, in order to do that, I'm going to have to figure out the line that is perpendicular to my original line. So I'm going to have to actually figure out the equation of the line here. Okay, so I'm going to start with that. So step 1, we're going to find the equation of the line perpendicular to the given line that goes through the given point. All right, well, my original equation is this. So that means that my perpendicular slope, if my original slope is 2, then my perpendicular slope is opposite reciprocal of that. So it's negative 1/2. Okay, so now I'm going to go, okay, y equals negative 1/2 x plus b. I'm going to use this point to help me, right, because this line is going through that point. So this is an x and this is a y. So I'll plug them in. Negative 2 equals negative 1/2 times 6, or 6 over 1, plus b. I'll reduce. So 2 can be divided by 2 one time, and 2 can go into 6 3 times. So you get negative 2 equals, now that's negative 3 plus b. Add 3 to both sides. So b is actually equal to 1. So I'll take that, plug it right back up in here. I get y equals negative 1/2 x plus 1. Okay, so I found the equation of the line perpendicular to the given line. There it is. So I got to find the equation. Okay, that's the first thing I do. Now what I need to figure out is, where do these guys intersect? Okay, so step 2. Actually, let me do this. I'll highlight things as I do them. So this is what I found. Okay. Now, what I want to do, I'm going to draw the exact same diagram. So this is y equals 2x minus 4. What I have now is I have this line. I'm just going to draw it as a segment, but it's going through this point, and it's also going through that point. I have to figure out what this point is. Because if I can figure out this point, then I can find the distance between these two, and voila, I'm done. Well, how do we find the point of intersection of two lines? Well, that's why we solve systems of equations. So now what we're going to do is we're going to solve the system to find the point of intersection. So my system is, well, this is one of my equations, and that's the other equation. These are my two equations that I have, and that's the system. And when I either graph them and find the point of intersection, or use substitution to solve, or there's also, the combination method, but we'll save that for next year. So we got y equals negative 1/2 x plus 1. That's one of my equations. And the other one is y equals 2x minus 4. That's the original equation. Well, they both are equal to y, so I'm just going to plug one of these into the other one. So how about I plug this value of y in for that one? So now I got negative 1/2 x plus 1 equals 2x minus 4. Let's get all my x's on one side. So I'll add 1/2 x to both sides. Okay, so let's see, that's going to give me 1 equals 2.5x minus 4. And then I'll solve for x here. So let's add 4 to both sides. Okay, so that's going to give me 5 equals 2.5x. I'm going to rewrite that as a improper fraction. So 2 and 1/2 is really the same as, well, 2 times 2 is 4, plus 1 is 5, so 5 halves. So I'm going to rewrite this as 5 halves x. And the reason I do that is because what if I'm not allowed a calculator? This can get complicated with division. To solve for x, I have to divide by 5 halves. But we don't divide by fractions. Instead, we multiply by the reciprocal. So I'm going to multiply both sides here by the reciprocal of 5 halves, which is truly 2 over 5. By doing that, this all reduces. And I'm just left with x on the right-hand side. Now on the left-hand side, the 5's also reduced, so I'm just left with 2. Thank goodness, I didn't want to work with fractions anymore. Okay, so now I'm going to take that x value and I can plug it into either one of these. So how about I'll just plug it back into this one. So we'll get y equals 2 times 2 minus 4. Ooh, or y equals 0. So the point of intersection is 2, 0. So this point right here is 2, 0. Okay, so I found my point of intersection. This little point right here. And the last thing now, basically what I need to do is to find the distance from 6, negative 2 to 2, 0, I need to find that distance, right? That's exactly what I'm doing. These lines are perpendicular, right? So I can find the distance between these two, and that will be the distance from the point to the line. So step 3, find distance between 2 points. And that's just the distance formula. So we'll go distance equals, and if you remember, the distance formula is x2 minus x1, or the change in the x's squared, and the change in the y's squared, and you add them together, and then you take the square root of everything. All right, so coming back up here, how about I'll call this my x1, y1, and this one my x2, y2. Okay, so nice reminder of how to do this. Let's see, I'm going to have 2 minus 6, we'll square that, plus 0, oops, why did I put a comma? 0 minus negative 2, we'll square that. I'm going to run out of room here, darn it, but that's okay. I'll go a little bit further. So this is going to be negative 4 squared. And this is 0 minus negative 2, which is in reality 0 plus 2. So that's going to be a 2 squared. Now I'm going to come over here. So this is a square root. Well, that's 16. Negative 4 squared is 16. And 2 squared is 4. So this is really the square root of 20. Now let's simplify that. Don't just put in your calculator. I want the most exact answer. So for your next test, I want to see these radicals simplified, not necessarily just decimals that you've approximated using your calculator. So the square root of 20 can really be rewritten as the square root of 4 times the square root of 5. And the square root of 4, in fact, is a perfect square. So it's 2 root 5. And there's your answer right there. So that's our distance. Now, they didn't give us any units to say. But if they did, and if this was a real world problem, then it might be more helpful to get an approximation. And so you could go onto your calculator and say the square root of 20 is, okay, well, see how this is not an exact number? So you'll round this to 3 decimal places. So 4.47, and I keep it at 2 because the number next to it is not 5 or greater. Okay, so I can also say that this is approximately 4.472. That would also be acceptable, but if I say in simplest form, if I say round to the nearest thousandth, then it would be this. And your book will probably give you answers like this, and I'm going to expect answers like this, so be able to do it both ways.